all the time you look at a pie chart?
If it's a categorical variable, you're going to make a pie chart. If it's a continuous variable, you're going to look at histogram. If there's too many slices in the pie chart, you make a bar chart.
Okay. Or bar.
All right, so question, hours of sleep on a school night.
Okay, so we're going to go in this pie. And now, why are we picking the top one?
Because we're looking at slices of a group. We're looking at each group of a group. The second one would be looking at summaries of different variables. So we would look at the count of people who did this and the count of people who did that and the count of people. So different columns.
Sleep and something else?
Yeah. So we're not, but those are for within subject variables. So we're going to use the summaries of groups of cases because we want to look at who are in these groups. And you can look at percentage or number. It doesn't really matter when you're looking at one. Until you start paneling, percentages are great. But as soon as you start paneling, it gets messy.
Okay. All right. So we're going to define slices by question 8.
Mm-hmm.
No. Okay. So rows and columns. That's
okay.
If we're going to start paneling.
So rows and columns are when we asking more specific questions about the sleep.
Yeah.
Which once we have a couple ideas, then we can start exploring that.
Okay.
Okay.
So good. All right, let's take a look and use charts. But what is?
Okay, so we don't use any of that stuff. No, unless you have a grant that you're producing very specific graphs under very specific conditions, then you make charts specified by that particular thing. Like some people want their graphs to look a certain way, so we don't bother with that. So yeah.
Okay. So yeah.
They always get loud. Between classes.
So okay, so we're getting an overview. We're looking at this. We're seeing that the majority of people are getting.
You use QN.
I used QN.
See the difference?
Not yet.
Go look at question number 88.
Oh,
hours of sleep on a school night.
Hours of sleep on a school night, and I did QN 88.
And you need Q88.
Had 8 or more hours of sleep. Period. I understand. And so QN, it's dichotomous variable?
QNs are the dichotomous variables, right? Two
and
choices.
So this is looking at had 8 or more hours of sleep. But it doesn't. Oh, and the survey they had 2 or more. Fair enough. All right, so let's not do that.
Let's leave it there. Leave it there because we can talk about that.
Okay. So a vast majority of these people had 8 hours or more sleep.
Okay, well that's good. That's what you should have. So let's go make the graph of the right variable now, because then we want to talk about the correct variable.
All right, so we're not doing QN 8. School night.
There you go. No, not there. Missed.
I got you.
There you go. There you go.
All right, this looks good. So hours of sleep on a school night. This is
So if I double click on the graph and stick the percentages on there, just the numbers. That's it.
Percentages. This one does percentages.
Yeah, that one does. That computer automatically does percentages. So what percentage of people are 4 to 5 hours?
4 to 5 hours. We have the blue and the green.
Yeah.
22, 23%.
Yeah. So then you look at about 22% are 6 hours, 22%, 28% are 7 hours, about 20% are 8. And if we added that little bit of extra of 8 or more, we could easily make 4 groups out of this that are equal percentages.
4 groups of wages. So 1, 2, 3, and then the rest. Of
Yeah, 4. That would be pretty close to equal percentages. So one of the important things when looking at trying to reorganize groups is you have to reorganize groups based on real differences. Is 4 hours really different than 5 hours, or is there a difference between 4 and 6 hours of sleep? And then so you start thinking about this in terms of the bigger connotation of pictures. Is that so? If you get 4 hours of sleep a night, is that different than getting 5 hours of sleep a night? Well, is 4 definitely different than 7?
Okay.
So you can start. I'm thinking theoretically here, not actually looking at. I'm not seeing any of this in here, but
Yeah.
but what you can start to look at is you can say, hey, we have enough subjects that we can test all of these groups. It's not a problem. But if we had a smaller sample size, we would want to combine 4 and 5 hours together to make one group. And that group would be about the same size as 6 hours, which would be about the same size as 7 hours, which would be about the same size as 8 hours.
Okay.
So anyway, so just by looking at this, so let's describe who these people are.
Okay.
Okay, so now let's find out. So we can panel this graph by male and female to see if the pie charts look the same.
Okay.
And then so when we panel it by male and female, if the pie charts look the same, then we can say, well, males and females sleep about the same. To actually see the numbers, though, what will we do?
Other than double clicking and switching it?
Yeah, then you start trying to look at little tiny slices compared to each other. What's the analysis?
With numbers, I remember is when you look at the crosstabs and put it.
Perfect. Let's do the crosstabs first.
Okay.
And then we can make the pie charts, because the crosstabs really tell the data. The pie charts can be misleading because each pie represents 100%. Even if there's only 4 people in each pie, it's still 100%. So it looks like, oh wow, look at all these people.
Yeah.
But it doesn't tell you the number of people. They're misleading. Okay, so go to Analyze, and then Descriptive Statistics, and then Descriptive.
So we're going to look at the data in terms of question.
I'm sorry, not Descriptive. Analyze, Descriptive, and then Crosstabs. Yeah, you were there. I was in the wrong one. I'm like, why is this wrong?
Personal preference, rows and columns.
So easier to understand if more categories are in the rows, less in the columns.
More in the rows, less in the
columns. And it's hard to understand, all depending on how you think about what you want to look at. I mean,
okay.
If you have like it's easy to look at 2 columns and then look down the list.
Okay.
But you can always make it whatever way you want.
All right.
It doesn't really matter. But we're just looking at frequencies. So I asked male and female.
Okay.
And so I'm going to put those in the columns on mine, because I like to have 2 columns to compare male and female with the same question.
That makes sense. That's good. All right, so male and females in both columns.
Question 88 goes question 88.
All right. Display cluster bar charts, suppress tables.
And then we don't need to show any statistics right now, because all it's going to show is frequencies.
All right, I'm just kind of wondering, is this anything that we ever did?
What?
The display cluster bar charts?
Yeah, we always do that.
We added the...
We'll always add the charts. Oh, and because, especially with the large numbers, don't click OK yet, or did you? Okay, good. So let's panel that by year. Put the layers by year.
Layers by year, okay.
So then we get a pile of graphs, but we get to look at change over time, which I think is important.
4 digits, year of survey?
Yeah, yeah, that works.
That goes in the bottom.
Mm-hmm.
Right.
And then so it'll automatically just panel it by years of survey. Okay. And then just hit OK, let it roll.
All right. Let's see.
This makes more sense than roll on. Look at the graphs. Don't look at all the numbers. We look at the numbers afterwards.
Okay.
Is this normally distributed?
It looks like it.
It does, because this hours of sleep per night is kind of continuous. I mean, it's truncated at either end, but it kind of looks like a normal distribution. So if we go back to the first year was 2005, they started asking this question.
Yeah.
Okay. And is there a difference between males and females?
Females are blue. It seems to be in the 6, 7, and 8 range.
Yeah, and it's the 6, 7, and 8 range seem to be higher female.
Yeah.
And so that's a little bit interesting.
Yeah.
And look at 2007. What do we notice between 6 and 8 hours?
6 and 8. It looks like the men are starting to catch the women and even surpass it.
What do you mean catch? What does that mean?
The men are starting to get as much sleep as women, 6 to 7, and actually getting more sleep.
There you go. That's okay. So women sleep less than males at the beginning. I mean, it is. So that when there's higher frequencies of females at the 6 and 7 hour, lower frequencies of males at that hour.
Yeah.
Okay, so we'll see if that continues on.
Okay.
Is that pattern the same? Let's look at 6 and 8 hours. Just focus on 6 and 8.
The two, not
the two opposite, right around 7. So 6 would be, and then 8. What do you notice about from 6 and below compared to 8 and above? I've never done this before. This is the first time I'm looking at this particular analysis.
6 and below versus 8 and above. All right, so let's see. At the beginning, women are dominating.
Well, don't say dominating because there's more.
Okay.
No, but you got to use if you use the right words, then it helps you understand.
Would you say there's a higher women? Let's see. There's a higher frequency.
Yeah. The higher there's more women.
Yeah.
Who sleep between 4, 5, and 6 hours a night,
mm-hmm.
and more males seem to sleep between 8, 9, and 10 hours a night.
Let's see.
See if that trend follows through.
I do see that in 2009. More women.
Definitely 2009.
And the less sleep, and men are definitely getting more sleep in 2009.
And then 2011, it seems to be, it's not quite as dramatic. But the more women sleep less is still consistent.
Yeah. And there's also a whole heck of a lot more people sample.
Well, yeah, the sample size, as the years go on, the sample size gets dramatically bigger. So the cool thing is look at 2013. Do we see the same thing?
Okay. We do?
Yeah, same thing. But look at the bars. We'll get to that next part next.
Mm-hmm.
So, based on looking at this, we have made an observation that females tend to sleep less than males.
Yeah.
So far, so good.
Yeah.
So, why?
Why indeed?
Okay, so this is something that maybe there's something going on here, but also something that I noticed. Look at the percentage of the bars. Look at the relative heights of the bars. So let's go back to 2005 when this started. Look at the numbers of people who said 9 and look at the numbers of people who said 4. Notice how it's pretty normally distributed. In other words, 9 and 4 are about the same.
Yeah.
So if you look at the numbers it's around 100 and something,
sure.
Right?
That's similar, yeah.
Yeah, but then as we go on, what happens in 2007? What happens to the numbers of 4 or less?
4 and less increased relative
to 9. Good. And then we look at 2009, it's close to being the same again.
Mm.
But then with 2011, we see
a lot
more 4 or less.
4 less than 9.
2013, we see even.
Is it even more?
It's I don't know if it's even more, but it's
definitely still more.
Still more. Look at 2015.
Oh, yeah. It's a big increase.
Yeah, it's a big increase relative to the 9.
Yeah.
And if you look at the 10 or more stays about the same size this whole time relative to everything else.
Yeah.
9 or more stays about the same size relative to everything else.
Yeah.
What seems to be changing is the 4 or less.
4 or less, yeah.
That seems to be changing more than anything else.
Yeah, especially even in The most recent.
Yeah. And so, again, that's something else to pay attention to. Okay, so what else could affect your sleep? So let's think of something else we could look at. So over time, the male and female change is about the same. We might want to go back and look at those people who sleep in 4 hours less.
Mm.
So that's something that changes. So what I'm doing is by looking at this data, I'm saying, hey, I'm noticing, just looking at it from the top, I notice that females tend to sleep less than males.
Yeah.
Okay? And I also tend to notice that the 4 or more hours per night numbers seem to be increasing.
Yep.
Right?
Yep.
The people who sleep a lot doesn't seem to change. The ratios are about the same. But more people are sleeping less.
Yeah.
Okay. So now let's focus on the let's look at the male versus female. Could we recode this data to look for some, or could we select cases to look where the interesting aspects of the male and female are? How could we either recode sleep or make it into a variable that we could look at?
Okay. So then, I mean, then that's I know how to do the select cases, and I sort of remember how to recode, but
Why?
as far as why, yes.
That's okay. So let's look at the 2015 data. Let's just stay in the current data because that is the same trend that we saw everywhere else.
Okay.
So what groups will we get that we could see differences between males and females?
The ones with the most contrast?
Yeah, that's a great way to look at it.
5 and 6 have them. Are you talking about
blue and green? Compare blue and green.
Well,
where are the differences?
I see a big difference in 5 and 6 between the blue. I don't.
Yeah, no. Okay, so look at the. If we calculated a difference score between the two, so up until 6 hours, females are higher than males. After 7 hours, males are higher than females.
Yep. See,
that's where the difference is, and the difference is somewhere less than 7 hours and then greater than 7 hours.
Yes.
You see that?
Yeah, I thought you meant compare the green and blue next.
Yeah, I am. So what I'm doing is I'm calculating a difference score between the green and blue.
Okay.
See, it's in my head. So like if you count the numbers of females at 5 hours, there's higher value than the number of males at 5 hours.
Yeah.
Okay, so and then when you look at 6 or 7 hours or 8 hours, 8 hours, there's higher numbers of males. It's flipped.
Yep.
So let's recode sleep into 3 levels.
Recode sleep into 3 levels.
So what groups do you want to lump together that have similar characteristics?
All right. If I would lump them together, I can see 2.
Well, I'm going to leave 7 alone. So 7's going to be its own group. Most people sleep 7 hours.
How about if we did put 5 and 6 together, 8 and above together, and 4 in its own group?
I would rather leave. We'll leave. We could do that, but 4 is a relatively small group.
Okay.
So yeah, maybe we could do. Let's leave 4 alone. I like that. 5 and 6 together. 7 in its own group.
Okay.
And 8 and 9 together.
8 and 9, and then we're kind of leaving 10 alone because
it's also a small group, and it doesn't seem to. It's the same. We could put 8, 9, and 10 together. I don't think it would really matter. It has the same basic shape as the other one, so we could put it together.
Okay, and why 7 in its own group?
Because 7, if you look back over time, 7 is pretty consistent. Well,
except for the first.
7's the highest frequency. And up in 2013, they're about the same. And the differences are not nearly as dramatic as they are. But we could lump 7 and less and 8 and above. That would work.
Do you like to have more groups?
Depending on your sample size.
Oh. Okay.
So if you have more than 30 subjects in each group, good.
Okay.
We have more than 30 subjects in each one of these groups. So it's the reason why I want to make it less groups is because if I have too many groups, it makes too many charts to look at.
Okay.
So let's make the same group again with that QN variable.
The same group again with the QN variable.
The same, let's make the same analysis again. Go to descriptive.
Okay.
And then use that QN variable. Maybe the guys that did the survey, or girls that did the survey, or researchers who did the survey know more than we do. Which isn't always the case, but sometimes it is.
So I'm going to take out Q88 and put in Q in 88?
Yep, exactly. Had more than 8 hours of sleep.
Oh, just period.
Mm-hmm.
And 8 or more hours of sleep. Period. Oh, shoot.
So that's you can just.
I didn't take it out.
I know, but you can put more in there.
Put it in that thing.
Yeah.
Alright. Alright, so Q88, male and female panel by year. Alright. Let's see what that was. Okay.
See if we lose too much information doing it this way.
Let's just see what I'm looking at here. So, what the difference was the dichotomous variable was the yes or no here. That's what makes this the QN.
Right. Had more than 8 hours of sleep a night.
Yeah.
1 is yes, 2 is no.
Yeah.
Um,
Not have more. Okay, so females had less days of 8 or more hours of sleep.
Yeah. So, I mean, basically, it kind of shows what we were showing. Here, scroll down, look at, and in 2005, it doesn't really show it.
Yeah.
But in 2007, you can see that had 8 or more hours of sleep, more males said yes to that. More females said no to that. Barely.
Yeah.
Barely. So then look at the next one down, 2009. That's kind of what we're looking for, but it's not nearly as dramatic or it's not nearly as interesting as the other graphs that we made, is it?
No.
No, because when you break it apart, you can see more differences than when you collapse it together.
Yeah.
So having 2 groups, you lose what you're looking at.
Yeah. In this case, yeah.
Yeah, and well, in a lot of cases, yeah, the more if you summarize too much, you lose details.
Okay. That makes sense.
And so the number of groups that you have is really important. And that's why when I go back, if you scroll back up, and I look at these graphs, they keep going back up. Yeah, they tell a different story.
Yeah.
So what else do you think might affect the sleep?
Okay.
So let's think about something else that would affect the sleep. I don't like using the dichotomous variable. I don't think the dichotomous variable is going to work. I think we should just keep with the 7 layer and just let it get ugly.
Okay.
Okay, what else would affect sleep?
All right, and when we start to ask these questions here, would we look at the data and see what the variables are and determine?
So when we go back, when we looked at this first, remember if we started out, let's look at these kids' sleep. Okay, that's where we first question. So the first thing we did is make a pie chart to see what questions can we ask. So the first pie chart is saying what are the different measurements of sleep that we have, right? So go all the way back to the top.
Let's look at that.
Yeah, no, just roll all the way back to the top. Yeah. This is a very good process. The first question, there's the dichotomous variable. Go down to the next one. This gives us, okay, we have 1, 2, 3, 4, 5, 6, 7 layers of sleep.
Yep.
Right? So, okay, so I can ask a question about these 7 layers of sleep. And so the first question I asked was, do males and females sleep differently? And our conclusion was, yes, that males tend to sleep more, females tend to sleep less.
Yep. Okay. When we start to think about what kind of questions we want to ask, we have to look at the questions that were filled out first. Do you think? I mean, because I can wonder maybe they're partying more. I don't know.
Well, so we can answer that question. Is there a way that we can infer how much these people party?
Maybe, but I don't want to say drinking, but
yeah, no, drinking behavior more than 5 drinks in a row, aka party.
I guess that's party.
Yeah, it's that or it's dark and lonely. So yeah, so we could ask partying. We don't have a variable, do you party? But we can infer partying by asking another question. But so initially we look at the reason I say look at males and females is just I know having an adolescent male, he sleeps a lot.
Mm.
My daughter does not sleep a lot.
Mm.
She is 15, he is 12. She slept a lot in 5th grade. He's going to sleep a lot in 7th, 8th, and freshman year of high school.
Okay.
Well, there's a reason for that. Puberty. When the kids are growing really fast, they sleep a lot.
Oh, sure. Sooner.
Yeah, girls go through puberty sooner. And so the girls generally start puberty in 5th or 6th grade. And by the time they're in 8th grade, they're pretty much done their pubescent cycle and they're into their early adult cycle. Okay. Boys don't really get there until their freshman, sophomore, sometimes even junior year of high school.
Okay. So
let's look at grade. Let's not look at years, because the year is pretty consistent across years. Let's look at grade in school. So let's go make the crosstabs and look at the sleep that they're getting freshman, sophomore, junior, senior.
What I wanted to do is see, well, how would I do that? And you're looking at the crosstabs because
the crosstabs break it down into the basic count of numbers of people who.
Okay.
Because if you let's scroll down, look at the crosstabs that we did with those right there.
The actual.
Yeah, these were the ones that you had.
Graphs.
Yeah, those graphs. Yeah. Okay. And so if you roll back up and look at the chart, it actually says 97 females said 4 hours or less, and 121 males said. So in 2005, 218 males, you scroll all the way up to the top of that one, 218 males said, I slept less than 4 hours.
Yeah.
I mean, so I have that, or 218 males and females. So I literally have exact counts and exact numbers and data. So when you're trying to communicate this to somebody, you can say, in 2005, 3,515 subjects were asked this question. And so that's your statistics. That's as detailed as you want to get. But at this level, we're not going to write a paragraph describing this data to someone using all those numbers. There's no reason to. It doesn't help the person reading it know exactly 102 females and 110 males slept more than 9 hours. That doesn't mean anything. But if you look at the general idea of the graph, by scrolling down and looking at the graphs, you get the picture that, wow, there's more females in the slept less than 7 hours column than males who slept in less than 7 hours column.
Okay.
Go ahead.
I do get that. Is there a way to make this without it being the crosstabs? Can you make a bar chart that would show this exact same thing?
Yeah, but for every single one, you'd have to go through and click bar chart, clustered, summaries of groups of cases. We could do that, but the nice thing about the crosstabs is you're setting up a question. The computer answers the question with numbers and a graph.
Okay. The reason I'm asking is because, I mean, I don't know if it would be intuitive yet if you just asked me to go do it, that I would go to crosstabs because I might not fully understand why I'm going to crosstabs.
Well, yeah, so the bar chart, the crosstabs is the main question. The nice thing about the crosstabs is it'll also do statistics for you to show what is statistically different. We don't know what that means yet, so we're not going to do that.
Okay.
But it will flag things that are interesting. It'll say, you need to investigate this. And we don't do that yet, but we look for things that are interesting. I think we should make a variable, I said it and I didn't really think about it, that sets 7 hours, less than 7 or greater than 7. Because remember what that variable was that we didn't see any differences was?
The variable that didn't see any differences.
When we scroll down, the dichotomous variable that they made, what did they use? Keep going down.
You mean down to where? Okay.
That one.
This one. They didn't use, what do we got here?
Now keep going down. Just look at the graph. What is the criteria they use to make that dichotomous variable?
Had 8 or more hours of sleep.
8 or more hours of sleep.
Oh.
What if we change that to 7 or more hours of sleep? Do you think we might see bigger differences?
I don't think so at the 7, but maybe
With 6.
6. I think it would start to look different.
Yeah. So anyway, we're gonna use the 7 level, so we're not gonna cut it down to 2. But you would sometimes, if you notice a natural break in the data, if you notice a natural, like we notice, hey, wow, the blue bars are taller on this side, but the green bars are taller on that side. There's a natural break in that data, less than 6, more or 8 or more. There seems to be a definite break. Okay. But okay, so the reason why we choose the crosstabs is because it's one program, one little code that does everything that we want it to do, versus going through and making 30 different bar charts.
Okay, and if you just want to make
one bar chart, you absolutely can.
Just do you find yourself doing that? Oh,
no.
Okay.
Because I make them all, and then I take the one I want, I hit copy, and paste it where I want to go.
Oh, okay. All right. So it's just, I'll be more inclined to pick a crosstab in the future, given that.
Yeah, and then the times you make specific graphs are when we start doing hypotheses. Right now, we're trying to describe the data. We're not making specific hypotheses. We're trying to come up with questions that we can ask right now. So we're data fishing.
Still data fishing.
And we'll be data fish for a while.
Okay.
And the next other set of data fishing that you'll learn is correlations. You dump all the numbers together and see what pops up.
Okay.
And then you go, hey, that's related. How? I don't know. You have to look at the data. And then you ask questions. Then the questions lead to making specific graphs. But so, I mean, those are great questions. So let's go look at let's look at age. So look at grade in school.
Okay.
So let's do that same crosstabs, descriptives, crosstabs, and get rid of. Let's leave male and female in there. Let's get rid of your survey, and post in 9th through 12th grade.
Let's see. Is that the one that says grade?
Yeah, 9 through 12.
8 or more hours of sleep. We're sticking with QN88?
Oh no, Q88. My bad. I forgot that we switched it.
Yeah. Okay, so we're looking at hours of sleep on a school night for males and females by grade.
Mm-hmm.
That's a good one.
Okay. Okay, see what it says. Okay, before you scroll down, don't scroll down. What do you think, if our hypothesis is true, if we think that it's because they're growing?
Okay, so if that's the case, I would think that males would sleep more on the earlier years than the later years.
Perfect. And then by the time they're seniors, it should be level.
Well, maybe. And with the women, I would think maybe the same. Maybe they tend to be earlier on, but yeah, by the end, maybe about the same.
Right. Well, let's scroll down and look. See what happens. See what we get.
Okay. So what is this? Males and females.
So the first one is the 9th graders. Okay. And we see the same basic pattern we've seen before.
How do you know? I'm sorry. How do you know it's 9th?
Read at the top.
At the top.
What does it say?
It says 1 equals 9th, 4 equals 12th, and
grade equals 9th.
So what am I?
That's 9th grade. It's right here.
Well,
that's the name of the variable.
Oh wait. Oh. Sorry. I was looking for 9th, 10th, 11th, 12th in this graph, but it's
no.
not.
So if you switched it around, it would. If you switch the rows and columns around, it would do that. It would say what you're looking for.
No, that's okay. I forgot that there's many other.
Yeah. Okay, you got it.
So this is 9th grade.
This is 9th. These are freshmen. We see the same pattern we saw before.
Yeah.
Okay, so nothing that exciting. So 10th graders, same pattern.
About the same.
11th graders.
Looks like
It's
Maybe.
the same. It looks the same, except
Yeah.
the 8, 9, and 10 seems to be leveling off. They're not nearly as different as they were.
Yeah. Well.
And 12th graders, oh, they're slowly catching up, huh?
Yeah. That's kind of odd that this. Well.
The differences definitely seem to be all the way. If you look at the 4, 5, and 6, 4 hours is still about equi, but 5, 6, and 7, 5, 6, and 7, 5, 6, and 7, 5, 6, and 7. So, you see why I'm looking at 5, 6, and 7?
Not entirely. They all kind of look the same except for the 7 at the end.
Yeah, well, I know. I'm saying 5, 6, and 7 look the same on all 3 graphs. 7 gets a little bit closer as you get to the end, but for 5, 6, 5, and 6 definitely female. There's way more females there than males.
Yeah.
So if you think about these 2 distributions,
which 2?
2 distributions. Okay, you have a distribution of females
and
a distribution of males.
Okay. Gotcha.
You got it?
Yeah.
And if I were to put those 2 distributions on the graph, their modes are in different places.
Modes are in different places. They're peaks.
Peaks are in different places. And the males are offset a little bit higher, and the females are offset a little bit lower.
What high and low relatives?
Higher mean hours. So
Oh.
So the males. So we can use or the hours of sleep and average that. Do you want to see if males have an average sleep that's higher or lower than females? Because those are hours. We can average those.
Yeah, I guess we could, but I think we already know. Yeah. Unless.
We guess, but we don't know because we haven't seen the number. So let's just go to, let's make a good old-fashioned bar chart. Okay, so go up to Analyze or Graph, and then Legacy Dialog, and bar chart. Let's do clustered. Let's keep males and females in there.
So we're doing cluster because there's 2 variables.
Right, 2 variables. And then now we're going to make one of these, but we're going to make a special one because we have a specific question we're going to ask. See how we're not using a crosstabs to do it now? We're going to make one that's specific.
A small scale crosstab.
Yeah, it's just so we're going to look at other statistics. So click near the top there.
Near the top, other statistics.
Yep. Click on that. We're going to show them a mean, and we're going to put question 88 there. Now this is not a great thing to use as a mean because it is a categorical variable, but the categories represent real values, nominal values. 6 means 6 hours. 4 means 4 hours. So we can average them. Okay? So we're going to have a mean of hours of sleep a night.
Yep.
Our category is going to be grade in school. And our clusters are going to be male and female. So category means what the x-axis is. Okay.
Category. And is it the same as in math? It's the independent variable?
Yeah, it's basically, but now we have this, the graph has 2 independent variables.
Oh. Yeah.
So, but what you always try to do is on the category, put the one that has more values. So like if you have like grade in school has 4 levels, freshman, sophomore, junior, senior. Okay, so those 4 levels, that you want to put those on the category, and then for each category, there's going to be 2 lines.
Okay.
There's going to be 2 columns. It's exactly the same graphs that we made before, except showing count of people. We're going to show the average sleep for each person.
All right, and if we flipped them,
we would have so we'd have one category for males. And 1 category for females, and be 4 bars on each one. Okay. What I'm interested in is I'm looking at the difference between male and female at each grade. So I want to have 2 bars for each grade to look at the difference between males and females at each grade.
Okay.
Does that make sense?
Yeah.
So if you think about it, and a lot of students would write it down exactly what they want to show, and then once you start understanding, oh, this is what I want to show, then I can put it then I can put it in the computer.
Nice.
People like to try to use the computer to figure out what they want to show.
Yeah, it doesn't work that way.
It doesn't work that way because you can make anything. wrong, or if people make these crazy amazing graphs by putting things in the wrong places.
Okay. I might look at both just to see, but I think I know. You. Oh,
And just said okay.
Yeah.
And this
Alright.
this basically answers our question.
Okay. So what are we looking at? Males and females by grade. Average hours of sleep on a school night. All right, and it's
Now the number is 4 because it's a 4-choice category, so that you'd have to actually extrapolate out to figure out the actual means of it. But overall, what do we notice?
that men overall sleep more than
Females.
females on
Until
school night until their 12th year, where it's about the same.
So that's kind of what we thought it would happen.
Yeah.
And so that's a pretty good hypothesis.
Yeah. Is it worth looking at the numbers to see
Not
how much?
okay. So it's a categorical variable, but because the categories represent nominal values, we can average them.
Yeah.
But looking at the average of a 4 or 7 choice variable doesn't make sense. So the meaning of the graph makes sense, but the meaning of the numbers don't make sense. It's hard to explain, but
okay.
but it's like if it's the numbers it's averaging is 1 through 7. 1 through 7.
Okay.
And so the average, if I put the numbers on the graph, it's like a 3.7 versus a 3.89. Does that mean hours? No, you'd have to multiply it times the scale. And so basically this is a little bit less than 7, that's a little bit greater than 7 hours. You'd have to compute a statement and figure out exactly what the numbers are, but it's not worth doing unless you're trying to publish this.
Yeah. All right.
But in general, you can kind of see what we thought would happen is true. That the average sleep for females, if you scroll back up and look just right at the graph above this one, that if you averaged up all the females, there's more females below 7, and there's more males barely above 7. It's not a huge difference. We're not talking groundbreaking differences, but is there a better variable that we could use?
Other than grade?
Other than grade that would really show what we're looking at?
I would think height. Is that?
Well, height is not necessarily a measure of sexual maturity, but BMI is.
Is it? Okay.
Yeah, because because it's a lot of women don't get taller so much, but they do get squishy.
Yeah.
And so that their curviness adds to their BMI, but even though their height doesn't. But males tend to gain height.
Yeah.
So
all right. So we can.
So let's look at. Let's go back to crosstabs.
Okay.
And you can kind of see what we're trying to do is we're just kind of getting a picture of the data.
Yeah.
And then we say, oh wow, and their age definitely I can see a pattern with the numbers. So then I make a graph specifically about age. But this graph is not quite there. So let's go back to crosstabs.
All right. I'm looking at hours of sleep, male and female, grade. So
instead of grade, let's put age in. Age. Okay. We can't put BMI in a crosstabs.
Okay. Hold on. Can't put BMI in a crosstabs. Why not?
Because it's not a category.
It's not a category. Oh, it's a continuous variable?
Yeah. And so what you'd have is you have every possible BMI in a giant chart. Because the computer will do it. It'll say, sure. And it'll probably take about 3 minutes to put every single BMI on the axis of a chart and then it would be a mess.
You can recode it for BMI categories.
There happens to be a value for BMI categories.
Okay.
So we could do that. Yeah, because we can easily recode if you want to be underweight, average weight, overweight, obese. Yeah. Then Weiner. Okay. So let's do it by age. Just panel up. Let's put the categories by age and make the graphs by age. Because if our hypothesis is really there, we should see the frequencies change with age.
Yeah. Okay. Is it the same as? Should it look the same as the grade? Because I mean, don't they kind of go together?
Look what it looks like.
Is the right thing?
Did you do by age? Keeps going down. You think you're too far. That's it. And you look, is it the right thing?
Yeah.
But, okay, so what about 12-year-olds?
I think this is not the thing.
It is the right thing. That's what, but look at 12-year-olds.
Okay, so where are we at? Look at 12-year-olds. Okay, so 12 years younger. Okay, they are.
All over the place.
Wow. 4 hours. Wow.
Yeah, okay, so are 12-year-olds who are in high school normal people? Have we discovered that already?
Yeah.
They're not. Something's off. Look at 13-year-olds. What do we see?
More numbers. Oh wait. It's also a lot smaller samples.
A very small sample size, and we notice that is the trend for males and females about the same?
As
what we've seen before.
Okay, good.
Except the 4 or less hours. That's, again, 13-year-olds in high school are probably physically mature but mentally very immature.
Yeah?
Yeah.
Well, the reason I'm saying this is I did know some younger people in high school, and they were just really smart, nerdy people.
Yeah, but gotta remember, this is a national sample. And a lot of the kids that get socially promoted in other places are because they're too big to be in middle school, so they push them off to high school.
Socially promoted, is that what you call it?
Yeah, well, a lot of kids in elementary school are pushed off to middle school without any. And I don't really think that there's any academic progress in a lot of my son's classes. There's just not a lot of academic rigor, and it's a lot more of following the rules and doing what you're supposed to do, and then you get passed through. But I think a lot of these kids for high school. Okay, so let's look at the 14-year-olds.
Okay, that's more.
Looks like what we should see.
Yeah.
And also females are 7 or less, and the males are 7 and more. Look at where the average would be if you were to draw a line for the. Yeah.
You said 7 or less or 7 or more?
So if it's 7 for most, the mode for the female seems to be right at 7.
Yeah.
And the mode for males is somewhere between 7 and 8.
Yeah.
So the distributions are really close. I mean, they're overlapping quite a lot, but they look a little bit different. So let's look at 15-year-olds, see what happens.
It's still the trend, but
it's still the trend, but closer.
Yeah.
And then 16-year-olds. Same. And 17-year-olds, uh-oh. What's happening?
Well, 7. Well,
look at the 7s. Look at the 7 hours.
Yeah.
You see how the males are equal now? Females are still heavier on the low side, but males are much more normal around 7. And by the time they're 18-year-olds, look at that. So it basically, if you think about it, it starts out like this, and then eventually lines up. The green graph and the blue graph start out apart, and then they eventually line up.
Well, they line up, and then
it actually even passes.
Yeah. Oh, all right. Well, that's supporting our theory.
Well, yeah, but you also look at the number of 18-year-olds. If you look at the graph, if you can roll back up and look at the actual numbers. So the number of 17-year-olds is 46,000, but the number of 18-year-olds is down to 19 again. 16-year-olds, 53,000. 15-year-olds, 52,000. What's happening as these kids get older?
They're not doing the survey.
Well, they're abandoning ship on high school.
Yeah, you think so?
Yeah, there's a lot of people that don't finish high school. It's hard to understand in our academic environment, but it's a lot of people who don't finish high school.
Yeah, I mean, can you draw that conclusion from this data? Or
no, you can do it from other data, not from this data.
All right.
Oh, I hate getting old. Okay.